Okay, this video is going to look at the volume of pyramids. We've looked at prisms earlier in this unit, and we said the volume of a prism, something like this down here is a prism. You can take the area of the base, so whatever the area of that bottom is, and multiply by the height. Today we're going to look at pyramids. So this here is a pyramid that comes to a point. Before we get into this, we've seen a lot of this lately, so let's continue. Let's find these unknown side lengths. So here you've got some right triangles, right? You can find the unknown side length using the relation a squared plus b squared equals c squared. Remembering when you do that, the legs are the a's and the b's. So those stay on the same side of Pythagorean's theorem. Good idea, pause the video, solve for C, solve for Y, and then resume the video, see if you did it right. Okay. In the first one, the legs are 5 and 12, so 5 squared plus 12 squared is going to equal the hypotenuse squared. Square the values. 12 squared and 5 squared are 25 and 144. Add them together. And then square rooting is always your last step in Pythagorean theorem. So you will get about, or exactly, 13 centimeters for C. B, the legs are y. So I'll have y squared and 13.7. So y squared plus 13.7 squared equals the hypotenuse squared. Now we can square these values. It's always our second step. Get 187.69. And then 15.9 squared is 252.81. On this example, I need one extra step to get y by itself. So I want to get rid of the 187.69. So that way on the left side, I just have a y squared. When I move it over the equal sign, I do the opposite. So it's a plus 187 on the left side. That means I'm going to subtract 187.69. Resulting in 65.12. Now I'm going to square root that. And you get that y is about 8.1 meters. Okay. We've seen these Pythagorean theorems sneak up in area questions. They are going to sneak into the pyramid questions today and the cones that we do later on. So good that you keep practicing this and get really good at this. Okay, so we're looking at pyramids today. So there's a bunch of pyramids down here. We've got this pyramid, this one, and this one. Basically what defines a pyramid is it has a polygon base. So here there's a polygon on the bottom. That polygon's a triangle. Here it looks like that's a square base, maybe a rectangle base. Here I have a pentagon base. And this one here looks more like a rectangle. So this one might have been a square. So each of these, those gray shapes are polygons, but they come to a point. Right? Each of them comes to a point compared to a prism that has the two polygon faces, right? So these ones come to a point, and we watched in class, we would have watched a video demonstration, but basically if you want the volume on any of these pyramids, you can take the volume of a prism. Remember, the volume of any prism is the area of the base times height. Rewrote it as this. Right? It's the same idea, but if it comes to a point, you can divide it by 3. Because what that means, and what the video in class showed, is if I have a prism that has the same base and height as a pyramid, 3 pyramids would fill the prism. Or if I have the prism, 1/3 of the prism would fill up the pyramid. So all of these formulas for pyramids will be the volume of a prism divided by 3. If it comes to that point, we divide it by 3. Your formula sheet only has one pyramid on it. It has a square-based pyramid. So if you want the volume of a square-based pyramid, you could use this specific formula. This one's specific to a square. This one up top can work for any pyramid. Okay, so we are going to need to find the volume of different types of pyramids, pyramids with different bases. And what changes is what is that area for the base. And you'll see that as we go through the video today and as we did in the lesson. Okay. So this is kind of where I'm going to focus at because this works for all pyramids. Okay. Here we have a question. The prism and the pyramid have the same base and height. Determine the volume of the pyramid. I'm going to do this a little bit uniquely. I'm going to find the volume of this guy. The volume of this, well, that's a prism because it has a rectangle on the bottom and a rectangle on top. So the volume is going to be the area of the base times the height. Well, the base here, this base, is the same as this. It's a rectangle. So I can do length times width for the base and then times the height. I'll try to color code this to help you. The base is length times width because that's just a rectangle. Okay, well, if I do that now, I'm going to get 3 times 8, length times width, times the height of 9. And you get 216 cubic centimeters. This pyramid has the same base and the same height. So if I want the volume and it has the same base and the same height, I can just use the formula, the area of the prism divided by 3. So 216 divided by 3, and I get 72 cubic centimeters. To go from here to that, if it has the same base and height, I'm just dividing it by 3 because the pyramid is smaller. Some questions that you get might give you the volume of the pyramid and ask for this guy. Well, the prism is bigger, it can hold more. You would just multiply it by 3. Okay. Let's look at a problem here. So now find the volume of the pyramid. If you look in your formula sheet, you do not have this shape there. You do not have a rectangular based pyramid. So you have to rely on the fact that you know that the volume of this thing is going to be the area of the base times the height divided by 3. Okay. All we need to do is find the area of the base. So when I look at this, I see, well, the base is a rectangle. The area of a rectangle is length times width. Oh, okay, that's going to be 6 times 12. That means the area of the base is 72 square yards. So in my formula, I can say, oh, area of the base is 72 times the height, which is 14, and then divide by 3 because it comes to a point. Just going to move this over a bit. Oh. Okay, now you just go to your calculator. 72 times 14. Divide by 3. A lot of students forget to divide by 3. You get 336 cubic yards because that's the volume of it. There you go. That is the process that you can use for all pyramids. What's going to be different is that pink stuff. Depending on what shape the base is, you're going to use a different area formula. The base might be a triangle, so you use area of a triangle. The base might be a regular polygon, so you use the regular polygon formula. The base might be a square, so you use a square formula. The base could be a parallelogram, etc. Okay, so you just use the formula that's for the area of that specific base. And that's it. What's different about these two questions? Because they look similar. I guess what's different about these two shapes, they look similar. They're both pyramids, right? They both come to a point, so they're both pyramids. So for both of them, I'm going to use this formula. This question here would be a single star question. This question's a lot easier than this one. The difference, what makes the second one harder? In this first question, you know the height. In the second question, you don't know the height. The height is always straight up and down. Right? The 10 yards that you see, that's a slanted height. Right? It's not perpendicular to the base. Even though you see this, it is still a slanted height. And in class, I'll have some 3D shapes to show what I mean, so you can see the difference. But the height here is in the middle. I don't know it. Okay. So a slant height, that's the distance from the top of the pyramid along the edge of the pyramid. But what I want is the height. The height would be from the tip of the pyramid straight down, perpendicular to the bottom. It's kind of like if you think of it as a mountain, right? Mountain, the height of a mountain is not measuring up the length of the side of the mountain, right? That's not the height of a mountain. The height of a mountain would be the perpendicular distance, that inside height from the tip of the mountain to kind of the base of the earth, right? When you have the slant height and you want the height, you're going to have to use Pythagorean theorem. That's why we snuck that in. That's why I snuck that warm-up in, and that's the difference. That's why this is a 2-star question. I'm going to have to calculate the height. But we know how to do that, right? So even though it's 2-star, everyone can do this. So let's go ahead and find the volume of this pyramid. The volume of a pyramid is going to be area of the base times height divided by 3. Okay, so first, let me find the area of the base. Here's the base. It's not marked very well. It should have these ticks to tell you the base is a square. So you could do length times width and 4 times 4, or you could say, oh, it's a square, so I can do a side squared, say 4 squared, and get 16. I can now sub that in over here. The area of the base is 16 times the height, and then divide by 3. We just talked about this. I don't know what that height is. The height would be that inside portion. And it'll have a 90-degree angle down there. I'm going to draw that just to the side here, just so it's a bit cleaner. The height meets the bottom at 90 degrees, and that slanted height is actually the hypotenuse. Do we know this side length here? Some students might say 4, but 4 would be that whole length. And that green triangle doesn't go across the whole square, it only goes across half of it. So that base is half of 4, it is 2. Now I can do Pythagorean theorem here. The legs of the triangle meet at 90 degrees, so it's going to be h squared plus 2 squared equals the hypotenuse, 10 squared. Square those numbers. Now get h by itself. So move that 4 over, and when I move it over, I subtract it. 100 minus 4, I get 96. Square root 96, and I get a height that's about 9.8 yards. Now I know that height, I can sub it in here. And I can do my calculation. 52.3 cubic yards. Yards cubed, right? Remember, volume is always cubes. If it begins with a V, it's going to end with a 3. So this is nothing new, right? Calculating the area of the base, we did that with the prisms. We're doing it again with the pyramids. But what makes this question harder is I had to do Pythagorean theorem to find the height. Let's do one more. Well, we're going to do 2 more, but let's do another one here. Find the volume of the pyramid if the apothem is 7.8 meters. Okay. I look at this shape, it comes to a point, so my volume formula is going to be the area of the base times height, I guess I don't need to do that, divide by 3. First thing I need to figure out is what is the area of that base. That base is a regular polygon. We've seen this for multiple days now. To find the area of a regular polygon, you take the perimeter times the apothem and divide it by 2. The perimeter here, each of these sides is 9 meters. So 9 meters, 9 meters, 9 meters, 9 meters, 9 meters, and 9 meters. I have 1, 2, 3, 4, 5, 6 sides that are 9 meters. That there is the perimeter. I need to multiply the perimeter by the apothem. The apothem is this side here, which the question says is 7.8. And here I just go to my calculator now. 6 times 9 times 7.8 divided by 2. And I get the area of the base to be 210.6. I can put that into my volume now. Okay, so there's the area of the base. Maybe I should put the units for the area there. Going back to the volume, now I need to multiply it by the height. Oh, this one's nice. This height, this line here, is a perpendicular line, so that means the height is actually 12. So I don't need Pythagorean theorem here. 210.6 times 12, then divided by 3, and you get that the volume is 842.4 meters cubed, cubic meters. All right. So we've seen this a lot. Doing it in one calculation is a bit nicer than doing a triangle and then multiplying it by 6, but you will still get the same answer if you do that. Okay. This question, this is a tricky one. All right, so this is kind of, we're going to finish with the hardest one like we normally do in our lessons. Here we've got the Ha-Ha pyramid that's in Quebec. It has a height of 21 meters. Its base is an equilateral triangle with sides 19 meters long. the first thing you would have done in class is drawn a diagram of this. To draw this, because you can see the picture there, so it looks like it's easy, but to draw this, it says the base is an equilateral triangle. So that's the first thing I would draw. I would draw the base and then put these lines in to say that it's an equilateral triangle of 19 meters. And then it says the height is 21 meters. So I would put a tip anywhere, doesn't matter where you make the tip of the pyramid, and connect that to each corner. And then the height is that straight up and down, which would be 21. And that's how you would go about drawing it. So that's the first part of the question. The next part says, find the area of the base and the volume of the pyramid. Okay, so like if it didn't say and separate as area of the base, volume of the pyramid, you would start by doing, volume of the pyramid is this. Mm-hmm. This question kind of separates it, and it wants us to find the area of the base first. So let's go ahead and find the area of the base. What shape is the base? It's a triangle. So I'm going to use base times height divided by 2. When I look at this triangle, I can see 19 is the base. The height would be this thing right there, which I don't know. But by drawing that in, I now have a right triangle. That's the height. The hypotenuse, remember it was an equilateral triangle, so the hypotenuse is 19. What's the base of that green triangle? 19 is the whole gray triangle. The green triangle is half of that. 19 divided by 2 means it's 9.5. So now I can use Pythagorean theorem again. The two sides, h and 9.5, make the 90 degrees. So that is the legs of the triangles. Those go together, a squared plus b squared. The hypotenuse across from the box is 19. That's c, so c squared goes on the other side. I'm going to do something slightly different here. I'm just going to show you another option. Instead of squaring it right now and having lots of decimals, you could move this term over and say h squared is 19 squared minus 9.5 squared. And then you can type all of that into your calculator. Sometimes if you have really big numbers or lots of decimals, this is easier. So you would just type in 19 squared minus 9.5 squared, hit equals, and you'll get 270.75. And we square root that number to get a height that's approximately 16.5 meters. That is the height of the base. I'm not putting that over there. That's not the height of the pyramid. This is the height of the triangle on the bottom. And it's over 2, it's not over 3 because I'm just looking at the area of a triangle, right? The area of a triangle formula is divide by 2. The volume of something that comes to a point, that's where the divide by 3 comes in. Okay. And you go to your calculator now, 19 times 16.5 divided by 2. You get the area of the base to be 156.75 square meters. And that, if I want to find the volume, is the area of the base. The height, I'm not looking at the 16.5, right? I'm not looking at that. That's the height of that triangle. Here, I'm looking at the height of the pyramid, which is 21. And when you type that into your calculator, oops, you get 1,097.25 cubic meters. Okay. So again, I had to use Pythagorean theorem in this question. It's going to sneak in a lot. Here I used it on the base. I knew the height here, but I used it for the base. And that is it. I'm just going to go back. If you get stuck on this, look at this question, because that's really what separates this first question here. That's just your basic 1-star stuff. So everybody, I hope, can do this one. Here, this is how we move into the 2 stars. Okay. So good luck with homework. Make sure you ask your teacher if you got any questions.